The AZ800 expects you to be an expert on HyperV and PowerShell. You can use PowerShell to create and manage HyperV virtual machines. During my studies, I started making functions to create and manage the virtual machines. This process of creating the functions helped me to gain a deeper understanding of HyperV, and it's left me with some neat tools I can use to reduce the amount of time it takes to set up labs. On my GitHub site, I have shared 6 PowerShell tools that make managing HyperV labs a bit faster and a little more fun. I also have the steps to create HyperV GoldenImages with a supporting configuration file known as an answer file. This unattend.xml is used in Windows installations to automate the setup process. Whether you're studying for the AZ800, the AZ801, the AZ802, building home labs, or just want to spin up VMs quickly, this toolkit is going to save you some time. So the main function is called new-lab_VM. And some things that it can do: it can create brand new VMs from ISO images, create VMs from pre-built GoldenImages, both desktop experience and server core, spin up multiple VMs at once, add multiple network adapters at the time of creation, and also automatically attach extra disks at the time of creation. There's also helper functions that add disks to any existing VMs, and then to also quickly initialize and format those new raw disks inside the guest operating system. It will also create all lab virtual switches with one command. It will save all running VMs for a fast resume. And there's also a nuke everything option, a reset button that will delete the VMs, delete their hard disks, and delete the HyperV switches, resetting your system back to where it was before you started the lab. So to get started, I'm going to remote in to my HyperV host. Once we get remoted in here, I'll show you the specifications of the laptop. So this particular model is a Dell XPS 9520. I've got Windows 11 Business, but you can do this with Windows 11 Home. It's got an Intel Core i7 with 16 gigabytes of RAM in 2 8-gigabit sticks. And now that we're on the host, I'll show you the PowerShell toolset that we'll use to create the golden image. And then once we create the golden image, we'll come back and show off the rest of the tool. So before we copy and paste it into the HyperV host, I'm just going to talk about each section of the script. So in this one PowerShell file, there are 6 PowerShell functions. This first one is called CreateLabSwitches, and it will create the standard switches that will be needed, which are private switches and an external switch to connect to the internet. So the first thing it does is it makes an array of the name of private switches. And then I use a for each loop to iterate through the list. And if the VM switch does not exist, then it will create the VM switch. If the VM switch does exist, it will spit out a message letting you know that the HyperV switch already exists. And then the next part of the function will take your HyperV host network adapter and make it an external switch. So in this case, I'm using a laptop and my network adapter is named Wi-Fi. You might have to change this depending on what your Hyper-V host is. If it's an Ethernet connection, it's probably Ethernet. Same format. If the switch does not exist, then create the switch, make it an external switch, and allow the management OS, set allow management OS to true. And so I'll show how this function works, but before we do that, I'm going to show the nuclear option, which is reset lab. So down here, the function's name is reset lab now. It will find all the VMs and stop them, delete their disks, delete them, and then if you are prompted, if you would like to delete your Hyper-V switches, if you say yes, then it removes the switches. So I'm going to copy and paste this into the Hyper-V host. So the name of the function is CreateLabSwitches. The connection to the Hyper-V host is going to drop here when it creates the external switch. So we'll hang out here for a second while it reconnects. But you can see from the verbose messaging that we've already created the AnkNet, the LinuxNet, Hyper-V switches, and those are private Hyper-V switches. It should reconnect here shortly. Excellent. So now if we go get VM switch, it tells us the type of switch and the switch name. Also, we can come up here in Hyper-V, Hyper-V Switch Manager, and then all of the names show up here in the GUI. If we wanted to reset the lab, we would reset the lab. All of the VMs would be deleted with their hard disks, and then you're prompted to remove the switches. In this case, I'm just going to say no, because we're going to continue on and demo the new lab VM command. Next, I'll go over the main tool, which is called new-lab_VM. Before I run the function, I want to go over each piece, just because it's a bit lengthy. This first part is called the synopsis, and it's used with the git help command. So when you use the git help command with the name of the function, we can use the examples parameter to show some of the examples of the command. This first one creates a new virtual machine with the external Hyper-V switch with 6 network adapters using a ISO image. This next example shows how the command creates 2 VMs using the AnkNet Hyper-V switch, configuring the VMs with 4 GB of RAM, and using the server core generalized image. And this last one creates a file server on the JUNNet Hyper-V switch with 6 GB of RAM, 6 disks. Each disk is 200 GB, using dynamic memory, and the generalized image for the desktop experience of Windows Server. So that's just to help use the function. So that is all stored here in the synopsis. So next we move on to the parameter definitions. So for this function, I use 3 parameter sets using 10 parameters. So the way this works is you have a parameter and you define its data type. For the virtual machine names, this is an array of strings. So you can use more than one name. This is just a string that you use for the HyperV switch. You can only use one. Then you can program in the amount of RAM, the adapter count, how many non-OS disks you want to have, the size of those disks, and then if you would like the VM to have dynamic memory. So all of those parameters are available in all 3 parameter sets. These last 3 parameters are exclusive. When you use one parameter, the other 2 become not available. So for example, if you choose to use the command with the generalized image for desktop experience parameter, then you won't be able to run the command with these 2 parameters. There's a few mandatory parameters, so the function will not run if you don't give it a name. It also won't run if you don't specify a switch. And it also won't run if you don't specify if you're using the ISO or the generalized image. The other parameters are optional and they have been set with default values. I found that most lab scenarios, the VMs can run on 1 gigabyte of RAM, but they perform much better at 2 gigabytes of RAM. So I've made the default for this function to be 1 gigabyte of RAM. So after the parameter definition, we start getting into the function, or excuse me, the meat of the function. So the first thing it does is it makes sure that the switch that you specified exists. And if it does not exist, it informs you that the HyperV switch name is invalid, and then the function will stop. Otherwise, it will proceed to the next part of the function, which is a for each loop. So for each VM name, in VM names, it will define the path of the VM configuration file, where it will be stored on the HyperV host, the name of the file, and the location of the GoldenImages, the size of the disk, the startup memory, and the processor count depending on your host. In this case, my HyperV host has 20 logical cores, so each VM will get 10. Then I use an if else block to create a VM depending on if you use an ISO or the generalized image for desktop experience or for server core. So if you use the generalized image for desktop experience parameter, it's a switch parameter, and that will set this value to true for the purposes of logic. So then this if block will be executed, and what it will do is copy the generalized image, which is stored in this case in the folder location C, GoldenImages, to the destination path, which is the default location for the VHDX files on the HyperV host. So once that generalized image has been copied to that location, the new -vm command can be created to actually create the VM command. It uses the VM name, the VM path. Its generation is hard-coded in as 2, the memory startup, and then the HyperV switch name. After the VM is created, then the hard disk is added to the VM. And in this case, I've added a DVD drive. So in the else if block, if you use the generalized image core parameter, the same code flow occurs, but instead of using the generalized image for server desktop experience, it will copy the server core generalized image to the location that the virtual machine needs the hard disk to be. Then we use the new -VM to create the server core image using the HyperV switch specified when you run the command. And then it will add the hard disk to the HyperV virtual machine right here. And then here it also adds a DVD. So the only reason you would need to add the DVD, it's nice just to have it in the lab environment, but also to run the ISO image. So if you do not specify using a generalized image, then you are prompted to use the ISO parameter. So this last block is an else block. If the ISO file does not exist in the path you specify, you will be notified that it is an invalid path and the function will stop. Otherwise, it will create the VM with the parameters. At this point in the code flow, regardless if you used a generalized image or an ISO image, the VM will be created. So the set-VM command is used to set the processor count, disable automatic checkpoints, and set the checkpoint type to production. The default is standard, and I also disable dynamic memory unless the dynamic memory switch parameter is used. Then we'll enable dynamic memory and set the minimum and maximum values to 1 GB and 8 GB. Next, I enable secure boot and set the boot order with the DVD drive first. In the case where you use a generalized image and no ISO, the boot order will just move on to the hard drive after it sees there's nothing in the DVD drive. At that point, there's a verbose message that says the VM has been created, but it hasn't been started yet. If you specified a number of non-OS disks to use when you run the command, this part of the code utilizes a for each loop to create the number of VHDX disks in the default virtual disk path on the HyperV host. Then the next for each loop gets the path of those disks that were created. And then we use the add-VM hard disk drive command with those disk paths to the virtual machine. So what this does is if you, for example, specify 7 non-OS disks, when you create the VM, it will create the VM with 7 hard disks attached to the VM plus the OS disk. And then the last piece of the function is the adapter piece, the network adapters. So this is a similar code flow. If there's less than one adapter, you'll get a message that says you can't have 0 adapters. If there's one, it just skips. But if you want more than one network adapter, then this will rename the network adapter and then add it to the virtual machine. And then at that point, the virtual machine will be started. So now we're going to bounce back over to the host. and we're going to create two virtual machines using the function, and those two virtual machines will be used to create GoldenImages, and then we will use the command to create virtual machines from the GoldenImages. Now we'll create our first virtual machine using the function. We'll configure this VM to be a golden image of Windows Server 2025 desktop experience. This golden image will allow us to create VMs with custom settings quickly. So the command is new lab_VM. So the first requirement is we give the VM a name. In this case, we'll use the name goldenimage-desktop experience. The next requirement, we must associate the virtual machine with a HyperV switch. So in this case, we'll use our external switch. In this case, I'm going to give the virtual machine 2 GB of RAM. They operate just fine at 1 GB of RAM, but you'll notice a performance boost when you use 2 GB of RAM with these HyperV Windows Server machines. So we're going to install the operating system from an ISO file. So I have some stored on my C drive in a folder called ISO, and we'll be using the Windows Server 2025 evaluation ISO. So I execute the command. After the command, we'll get some nice verbose output about the procedure, but we can also monitor everything from the GUI. So we can see that the virtual machine has been created. It's up and running with the 2 GB of RAM. So we'll go in and inspect some of the settings. So one of the main things is dynamic memory has been disabled, and there are 10 virtual processors. This is the nice verbose output from creating the virtual machine, but I just want to bounce back over to show the number of logical processors on the host is 20. So every virtual machine will be created with half of the host logical processors, which is 10. So the way that this works is the script will pull in the number of logical processors of the host at runtime. So if your host only has 16 logical processors, each VM will only get 8. And then you could be even more conservative here and make this a 4. But in this case, I found that 2 works just fine. So now that we have, and then we'll just real quick talk about checkpoints. Production checkpoints have been enabled, and then automatic checkpoints have been disabled. This is the file path for the virtual disk at C program data, Microsoft Windows Virtual Hard Disk. And we can see that the VM that is running, this is where HyperV stores the virtual hard disk files. So we'll come back to that in just a bit. But for now, we're going to connect to the virtual machine and do the configuration before we use sysprep to make it a golden image. So what's happening here is the virtual machine is booting from the ISO file. So when you see this screen at boot up, you have to hit Control-Alt-Delete, and then we see the press any key to boot from the CD or DVD. And this will launch the ISO from the virtual hard disk, and we'll see the Windows Server installation wizard. So I'll prompt through the installation wizard. So the main thing is to pick Windows Server 2025 Data Center Desktop Experience. And then for the disks, we'll click on Create Partitions and Apply so that we get the system partition and the reserve partition. We'll install the operating system on the primary. One of the big things I've noticed with Windows Server 2025 in the desktop experience is the GUI looks identical to Windows 11, where in Windows Server 2022 it looked more like Windows 10. So I'm going to time compress the video here just a bit while the operating system installs. When we get through this first installation screen, the virtual machine will reboot, and then we'll see another little installation screen before we'll program in the administrator password. So here the virtual machine is rebooting. And sometimes you will have to reconnect. The screen will kind of go dark during those key transition times. And yes, and you can see now that we've reconnected, we get this secondary installation screen. And then when this gets all the way to 100, we'll be prompted to enter the administrator password. Okay, so we are prompted to enter the admin passwords. Let me type a good one in here. Okay, so now we have gotten to the login screen for Windows Server 2025. So we'll plug in our admin password. Okay, and now we're on the desktop here. So I'll go over the golden image configuration. What we're going to do is install Python, and then we will make a custom Python app that will be stored on the desktop. And then that way when we bake that into the golden image, every time you create a new server, the desktop folder will have the custom Python app. And then we're also going to set a wallpaper that will be configured by using a unattended XML file, also known as an answer file. And then we'll use sysprep to configure the .bhdx file to be our golden image. So we'll go ahead and get Python downloaded and installed. So depending on your internet connection, this can take not very much time, but I'm on a bit of a slower connection, so this will take just a second here. In fact, I'm going to go ahead and time compress the video. Oh, I guess not. So the Python installer has been downloaded, and now we're using the start process command to install Python. Then after Python is installed, we'll reboot the virtual machine and make our Python app. Okay, so the virtual machine is rebooting. I'm going to bounce back over to my script here. So this warning message is just letting you know that it can't find this file and do you want to create it. And the trick is I'm using .py to make it a file that Python can recognize. So now even though this is open in just Notepad, the computer will recognize it as a Python file. So now we will plug in our code for the Python app or program. And we'll save it. And so now we've got this neat little Python app. And so to execute it, well, first I'll just show that Python is on the machine. Let's go Python version. So we have version 3.12.6. And so when we double click on this file, it will create two TXT files that have what I call the Unicode alphabet. So we'll go ahead and take a look inside here. So before Unicode, there was ASCII, and that's basically the English language, all numbers and some special characters. But as you can see, when you scroll down, it has all of the languages of the world. When we get down in here, you can see some of the Asian languages. But what's really fun in here is the emoji section. So here is a baseball. So you can kind of have some fun because you might just think the only keys are the ones on your keyboard, but you can have all these different characters. Another example is Alt 247 is the approximate character. And so now that this app is here, we'll bake it into the golden image. So the next thing we're going to do is download a custom wallpaper and set it as our background. And so I've got a wallpaper picture on my GitHub site, and I made a folder called custom inside the Windows folder where the other default wallpapers are stored. So I'm going to use the GUI to set the background. Just grab the file path real quick. There is our background. And so again, the answer file will bake this background image so that when you create virtual machines from the golden image, every time a user logs in, this will be their background. So that's all the configuration that we're going to do from the profile. For example, you could set the time zone, but we're going to do that in a little different. So this is the answer file. Its name is unattend.xml. So this first section I've just kind of future-proof. I've just coded in the generalized pass. but it actually doesn't do anything, but it's just here if you want to experiment and add stuff. So this is where a little bit of the secret sauce lies. When you come into the profile and configure it the way that you want. In this case, we did the custom app on the desktop, and the background image, we could have done the time zone. You can, let me get back to the code here. In the specialized pass, there is a copy profile action you can use, and we set it to true here. And so that is how we are able to get the background image baked into the golden image. So on the next pass is called OOBE system for out of box experience. And here we're going to create 2 local accounts, 1 administrator, 1 standard. So here we set the password value and we make the username Megaman, and then we put Megaman in the administrators group and make the display name Megaman, and then that way every time you create a virtual machine from this golden image, the Megaman administrator account will be there on the computer. And then we also have a standard account. It's the same process with the password. In this case, the user's name is Rush, which is Megaman's dog. And then the OBE to skip some of the prompts on the out-of-box experience, so that all we have to do is click next once and enter the administrator password. So this speeds up the out-of-box experience. So what we need to do is get the XML file downloaded to our golden image. And so we can use the invoke web request command to do this. So I'm back here on the golden image. I'll use the invoke web request to get the XML file from my GitHub repository and then place it in this specific file path of Windows System 32 sysprep. And then this is where I have stored the answer file, which is named unattend.xml. So at this point, we're ready to run sysprep and then create the golden image. So sysprep is stored at Windows System 32 sysprep. So I put the literal path here to start the sysprep program. And then I've run it with the generalized parameter, the OOBE parameter, and then shutdown. And the key here is to use the unattend flag and then the location of your answer file. So I'm going to execute the sysprep command. So after the sysprep process has completed, the virtual machine will shut itself down. And here you can even see that it's letting us know that it's going through the generalized phase of sysprep. I gave it just a bit of extra time, but this does happen where after sysprep, the HyperV virtual machine doesn't turn itself off. But if we just go turn off, then we'll be good to go. And so whenever you sysprep a machine, you never want to turn it back on. So what we're going to do here actually is delete it. Now we haven't actually deleted the hard disk. We just deleted the VM and all of its settings. But the hard disk is stored here at the C program data, Microsoft Windows, and then the virtual hard disks folder. So what we're going to do is take this .vhdx file that was the hard disk for our golden image that we just configured. And we're going to move it to a location on the C drive that is called C GoldenImages. So now whenever we use the generalized image DE, the desktop experience parameter, the function will copy this hard disk from this location to the virtual hard disk folder, this folder for HyperV, when it creates the new virtual machine. So we're now ready to create our first virtual machine from a golden image. So I did close my terminal, so I just have to rerun the function definition. So now we will do new lab VM. We'll call it Yahoo. And then we have to associate with a switch. So we will do the external switch with 2 gigabytes of RAM. But this time we're going to use the generalized image for the desktop experience. We'll bounce back over to the HyperV window. We'll monitor the install. So this takes just a bit more time because it's copying the .vhdx file. So we can actually see here it's the vhdx file was copied from C GoldenImages and then placed here. So now we see the machine is up and running with the 2 gigabytes of RAM, and we get this nice verbose output about how the procedure went. And here's the name of our VM, Yahoo. So now we'll connect into it. So this is our desktop experience virtual machine that was created from the golden image. So instead of launching from the DVD drive and going through the installation wizard, we've copied the .vhdx file. So this is the only out-of-box experience window you'll see. So we just click next, and then it prompts you for the administrator password. So plug that in here. And the first thing you'll notice about the this new virtual machine is that the 2 accounts have been created. So we see we have not only the administrator account, but we also have Megaman and Rush. So we'll log in as Megaman. And this is the first time login, and we can see we've got our background image that we set in the golden image. And then we'll confirm the time zone here. So right now the server says the time is 9:47 p.m. And I think this command just tells us that it's set to Alaska Standard Time. Oh, oops, I forgot an E there. So yes, Alaska. So the VM is set to Alaska Standard Time. And you can see it here as well. So that it's 9:48 here in Alaska. And then we just use the PowerShell command to confirm that the time zone setting was set by the answer file. And the other thing that was done with the answer file was the creation of the 2 user accounts. And so we are in the Megaman account. And you can see here is Megaman and Rush. And when we look at the groups, in the administrator groups, we can see that Megaman is in there. And then the last way we can verify that the golden image was used is we have our nice little Python app here. We double click on the Python app, and then it will generate the Unicode alphabet. So we can see all of the different characters. And there's our little baseball. And so you can see how much faster that was instead of installing the operating system from the ISO. So now we'll just rinse and repeat the procedure, but we're going to make a server core golden image. To begin, we need to create a new virtual machine. So we'll use the new lab_VM command, give it the name GoldenImage-server core. Then we have to associate it with a HyperV switch. I'm going to give it 2 GB of RAM. And we use the exact same ISO that we did with the desktop experience, which is the ISO that we're using is the Windows Server 2025 evaluation ISO. So I execute the command. And then we can also monitor here from the GUI. So we see that the virtual machine has been created and it's up and running. So we'll go ahead and connect in. And just like with the desktop experience version, you have to hit Control-Delete, press any key to begin the Windows Server installation. Then we'll run through the wizard. And this time we pick Windows Server 2025 Data Center. And the way that you can tell that it's core is it does not have desktop experience next to it. So now we're installing the server core version of Windows Server 2025. We'll create our default partitions and install the operating system to the primary partition. So I will time compress this just to save a bit of looking at loading screens. Okay, and then here goes the first reboot. And then there's that second installation screen. Sometimes the Hyper-V windows will black out, but you can check on them with the thumbnail from the Hyper-V GUI. And a lot of times if you just close and reconnect, it will refresh whatever was going on. So we can see that the installation process has completed. So now we're going to program in default password. So for this, we'll just do required. And then we get to the sconfig screen. So we're just going to exit out to PowerShell and begin the configuration. So the configuration is going to be identical, except for we won't set the desktop background because server core is all command line. So here I am downloading the Python installer, and then once downloaded, it will install. This may go pretty quick on your system, but I'm on a bit of a slower connection, so I may time compress this. Oh, well, that was pretty quick. And then so now that the Python installer has been downloaded, we're using the start process command to install Python. Then we'll reboot the machine, and then we'll create our custom Python app. One neat thing about Windows Server Core is you can still use Notepad. So we'll demo that here in a second. Put in our default password. So we'll exit out to PowerShell. We can see Python is installed. So now we're going to create the yahoo.py file on the desktop. And when we do this, we get the Notepad window. So this gives us a convenient option to just copy and paste our configuration here. So I'm going to go ahead and get our Python app. And then we'll save it. So now our custom Python app is on the desktop. So we're skipping the wallpaper, but we still have to get our unattended XML file. So it's the same configuration that we used for the desktop experience. So we've got our answer file, which is this unattend.xml, and it's been downloaded to this Windows System 32 sysprep folder. So we're now ready to actually run sysprep. And then again, the key here is to use the unattend flag and then the path to your answer file. So I'm going to hit enter and execute sysprep. And even in Server Core, you still get this nice little GUI about what's happening with sysprep. And then we'll keep a close eye on the time that the machine is running after sysprep completes, and then we may have to turn it off like we did with desktop experience, but we'll just kind of hope that it shuts itself down here. So the GoldenImage virtual machine is not turning itself off. You can give it about 5 minutes or so, but then it's okay to go ahead and turn it off. So we're going to go ahead and delete it so that we never turn it on again. And again, that doesn't delete the hard disk file. It just deletes the VM and its settings. So next we'll actually grab the GoldenImage from the default hard disk location for HyperV, which is Program Data, Microsoft, Windows, Virtual Hard Disks, and then we can see our GoldenImage. And then we're placing that in our folder on the C drive, which is GoldenImages. So now we've got our GoldenImages set, And from this point on, whenever we use the function, we can always use a golden image. So as long as you have your golden images in this file path, then you can create virtual machines from golden images. And they have to have this specific name for the parameter to work correctly. And then we get this nice verbose output of how the procedure went. So we'll go ahead and create our first two virtual machines from the server core golden image. And so what we do is just a comma separated list. So in this case, the first VM will be Yahoo 2, and the next PC will be Yahoo 3. They will both be using the external switch. And we'll just keep it at 1 GB of RAM. And we're going to use the generalized image for server core. So we'll monitor the process here from the GUI. And the reason there's just a bit of a delay is because it's copying the .bhdx file from the C golden images path to the default path for HyperV disks. So we'll go back into the folder here. And we'll see that Yahoo 2 and Yahoo 3 have now been created. So it was copied from that folder on the C drive where our golden images are stored, and then pasted here is with the name that matches the running virtual machine. So we've got our virtual machines running. So we'll go into Yahoo 2. Okay, there's just a little bit of a delay there for the first time boot up. And so now I was on 3 there. So there was a little bit of a delay there on the first boot up, but we'll connect back in here to Yahoo 2. And the first thing it wants us to do is configure the administrator password. So we'll program that in there. Okay, and the first thing we'll do to confirm that the golden image was used, as you can see here, we have our Mega Man and Rush accounts along with the administrator. And Mega Man is also part of the administrators group. And the time zone is set to Alaska Standard Time. So you can see how much time the golden image can save you when you start creating more than one virtual machine. So now going forward with the rest of the labs, whenever I need to create a virtual machine, we'll use these golden images. And I did quickly just want to show the Python app. So we'll change to the desktop and we'll find the Python app there on the desktop. And the way that you run it is you type Python and then the name of your app. And so now we can see that the Unicode alphabet has been created. And then what's neat is on server core, we can actually use Notepad to open it up. And then we can see the Unicode alphabet inside here. So this concludes how to make the Hyper-V virtual machines using desktop experience and server core. And then we'll have just a bit of fun here at the end. So we got all of our little skiers and our baseballs. We're back on the host, and I'm going to use the reset lab function to delete the virtual machines and their virtual hard disks. So we've got these 3 virtual machines, and these are their hard disks. I'm going to run the reset lab now command. It's going to shut down each VM, delete it, and then remove its hard disk. And so we get this nice verbose output letting us know the steps of the removal. And we can see that the virtual machines are gone, and so are their hard disks. So the last 3 functions we're going to talk about are add disks to VM, Initialize-RawOfflineDisks, and SaveAllRunningVMs. So this function will add virtual disks to an already existing virtual machine. So there's a few parameters. The VM has to have a name, and also must have a disk set name. And then you specify the amount of disks, non-OS disks, that you would like, and then the size of those disks. And then for each disk in the number of disks, you create a new VHD file at this path with the disk set name, and then the number that the disk is, and then specify the size in bytes. And then I utilize another for each loop to iterate through the disk count, and then we take and build this array that is the disks, and we get the file path of each .bhdx file. And then for each disk in disks, we add that VM hard disk drive to the existing virtual machine. So this next one is for inside the guest operating system. It's the Initialize-RawOfflineDisks. And what this will do is get every disk that is connected to the virtual machine where it has the properties offline and raw. Then for each disk in that array, which is the disk's object, it will initialize the disk at that disk number with the GPT partition style, create that partition using the maximum size of the drive, and assign a letter, and then we format it with the resilient file system. So for example, if you have 26 attached hard disks, it will iterate through all 26 disks and format them with the REFS file system. And then the last function that I have in the PowerShell script is this one called SaveAllRunningVMs. And it's basically the magic happens in this one-liner. We get all of the virtual machines that are in the running state, and then we save them. So that is all of the code of the PowerShell script and its 6 functions, which are also known as tools, PowerShell tools. So we'll bounce back over to the host, and I'll build a file server with 7 OS disks that are 250 gigabytes. And then after the virtual machine is created, we'll add more disks to the virtual machine. So I'm going to use the new lab VM, call it file server 01, use the external HyperV switch. And this time we're going to use 7 non-OS disks. And we'll make them 250 gigabytes. And for the RAM, we'll give it 2 gigabytes. We're going to use the generalized image of desktop experience. So I'll execute the command, and then we'll monitor the process in Hyper-V. This first delay is the copying of the .vhdx file from the golden image location to the default .vhdx location for Hyper-V VMs. So we can see the file server has been created. Now it's creating each of those virtual hard disks. So we asked for it to create 7 of the disks. It's creating them. And then it will attach them to the virtual machine and then start the virtual machine. So one way we can verify the disks is to go into the default location. And we can see we have the file server OS disk, and then these are the attached disks that are raw and offline. So since we used the golden image, we can pretty much log right into the file server. So I'm going to connect in here. Plug in an admin password. Then I'll use the Mega Man administrator account. Let's go into disk management, and then we'll see all of the raw offline disks here, and there's 7 of them. So before we do the initialize RawOffDisks, or excuse me, the initialize -RawOfflineDisks function, we're going to use the add disks to VM. So bounce back over to the host. Add disk to VM. The VM name is file server 01. The disk set name, we'll call it set 2. And we're going to add 10 300 gigabyte size disks. So now it's creating the virtual hard disk files, and then after they're done with being created, they'll be attached to the virtual machine, and we get this nice verbose output for each of those 10 disks. We get this verbose output that it's adding the disk to the file server. So we'll refresh here. Now we have 17 disks. So we have the 7 that we started that were 250 gigabyte, and then we added 10 more that were 300 gigabyte. So this makes adding the virtual hard disks to the virtual machine much more efficient, and it's much quicker to just use the function and add them like that than using the GUI and creating 17 disks with the GUI. Similar problem with then you'd have to go in and format each one, but we can use a PowerShell script inside of the virtual machine to configure all of the disks with the REFS, or you could do NTFS file system. So we'll copy the function. And now it's going to get, when we run the command, it's going to find all of the disks that are in the raw offline state and then format them with the REFS file system. So now we'll use Initialize-RawOfflineDisk. And we'll get this nice verbose output messaging, letting us know how the process is going. And then we also get a loading bar, giving us some more information about the formatting of the volume. So there's 17 of these, so we'll just let it iterate through all 17 disks. And we'll just take a peek. And you can see all of the disks are starting to pop in here. So we've got our E, F, G, H, I, J, and K that are the 250 gigabyte disks, and then the other 10 are being formatted and then presented here in File Explorer. This is a great opportunity to demonstrate the Reset Lab Now function. So before I reset the lab, I'll bring up our file server. But I also wanted to bring up all of these disks. So now that we've created the OS disk plus 17 other disks, we can use the Reset Lab Now command to not only delete the virtual machine configuration, it will also come through here and clean out all of your .vhdx files. So that is a bit dangerous, so only do that when you're absolutely ready to reset your lab. In this case, I'll say no, because we'll have more labs to continue on with. So that concludes the HyperV QuickCreate toolkit using GoldenImages and a answer file.
Thank you for watching, everyone! To celebrate, I have a surprise! Ta-da! A celebration banner! Thanks again for joining me!